All right, so the first thing we're going to talk about today is percentiles and quartiles. Again, percentiles tells us what percent of the total frequency scored below that measure. Percentiles measure position from the bottom. So let's suppose I gave a really difficult test in here, really difficult, and the top score in this class was you didn't know it, but you got the top score in the class, and you got a 70. And you're like, oh my gosh, I got a 70 on this test. But I tell you that that 70 you scored at the 90th percentile. That means that percentile means score from the bottom. You did better than 90% of the kids in here. And then only how many percent did better than you? 10. Okay? So a score, so that 70, was that a good score?
Yes.
That's a very good score, okay? Because you did better. That means that tells us that the test was maybe a little too hard. But on the next test, you got a 70 again, and you were hoping that that was at the 90th percentile. But this time, that score was only at the 50th percentile. That was average. Isn't 70 kind of average? So if the next test, you were at the 70th percentile, at the middle 50th percentile, sorry, a 70 was the 50th percentile, that means half the people did better than you, and the other half did worse than you. Okay? Does everybody understand that? Another example is that when you are born, remember I said the doctor weighs you, and they take your weight, your height, and your head circumference, all three of those, and they measure them against about 1 million kids that were born the prior year. Okay? Now, kids that were within the first month weighed and then tracked within the first year, you're all tracked, okay? Usually by like 1, 2, that kind of tells us what your growth pattern is going to be like. Like when I was born, I was at the 10th percentile, okay? That means only 10% of the babies are smaller than me. I was like 5 something, almost 6 pounds, okay? That means most kids were bigger than me, okay? So my doctor said I was going to be short. He kind of knew, right? Maddie, how tall are you? 5'3". She, for girls, was probably when she was a baby, she was like smack in the middle, 50th percentile. Half the kids were smaller than her, half the kids are bigger than her. And even today, if you look at yourself, you probably say that half your friends are probably shorter than you, and the half are taller. Yes, Lex?
But I'm short, but I weighed like 6-something pounds.
Yeah, that's tiny.
But like everyone else in my family that's way smaller than that, but they're all big.
That's why you have to take the average of your first kind of 6 months to a year. So initial birth weight doesn't always mean that that's how you're going to be. Okay, that just means maybe the pregnancy didn't, maybe you were born a little bit too early, which is fine. You can be born a little early, it's fine.
5 days early.
5 days early, that's not a lot. But, that means, your growth spurt will come at different times. How tall are you, Rihanna? 5'3"? I thought you were taller than that. How tall are you, Amelia? So Amelia at 5'7", she is over here between the 50th and the 100th, which is what's between 50 cents and $1. What's halfway between 50 cents? So she's at the 75th percentile. So when she was little, probably about a year old, the doctor said, probably knew she was going to be tall. At a year old, her growth pattern was that she was probably bigger than 75% of the babies, and only 25% were bigger than her. And if you look at your friends now, Amelia, you're probably taller than most of them. There's maybe 1 or 2 that are taller than you. Okay. I had a friend, remember I told you my friend that he was 6'5", and his son now is 6'9". At 2 months old, the doctor could already tell him that 2 months old, he was off the charts. He was over, there was no other babies. He was at the 100th percentile. Every baby was smaller than him. He was huge. Not only was he tall, he was chunky, like really the cutest baby, but just, 8 all the time. Okay?
So they like if you're going to be taller.
Usually by the time you're 2, they can tell you how tall you're going to be. Okay?
Do they tell their parents?
Yeah, they'll tell you. Yeah. Huh? You're taller than me, Rihanna. You're good.
Really?
Yeah. I say anybody that's taller than me is doing really well. Okay, so that's this is how you do it. To find your quartiles, you arrange your data in ascending order from left to right. You always find the middle first. I can show you by hand and how to do it in the calculator both. Then you find the middle of the lower half, and you find the middle of the upper half. And that's your middle of your lower half. So first you're going to find your second quartile, or your Q2, or your 50th percentile. There's 3 names for all these. Then you find your middle of the lower half of the data. That's called your lower quartile, your Q1, or your 25th percentile. Again, the middle of the upper half is the upper quartile, the Q3, or the 75th percentile. Now, the middle 50% of the data, we're going to call it the box, is what really we're interested in. That middle box is called the 50th percent of the data. That's your Q1, your Q2, your Q3. Now, they've done it for this. Let's say we had a set of data of test scores, okay? And we'll call this maybe 70. We'll call this 50, and we'll call this maybe, we'll call that 90, okay? All right, so we can say the middle score here is like what we talked about before. The middle score here just happened to be 70. All right, so we're going to find this data. This is going to be called our 5-number summary. When we do box and whiskers, we have to list our min, our Q1, our Q2, our Q3, our max, and we're going to, I'll show you on the next page, we're going to graph them. I'll show you how to make the box around it, and then we have to connect our min and max. These are called our whiskers, and this is called our box. You kind of don't really have to know that. Sometimes they just call it a box plot. They don't say box and whiskers. They could just say box plot. Okay? And as teachers of students, do we want this box to be really big, or do we want it to be smaller? Smaller. Smaller, because that means all you guys kind of did the same, right? If the box is really big, then we had some people doing really well, but on the other hand, we had some people doing really not well, okay? So if we look at this one here, these test scores down here, the middle right here, you'll have to sometimes be able to read this off your graph. So again, we'll do the min, Q1, Q2, Q3, and the max of this graph. This one has numbers on it, so we can actually do it. Let's see, this looks like it's going by 10, so this is 50, 60, 70, 80. It looks like my Q2, my middle, is 80. That was a pretty high middle. It looks like my Q1 is between 60 and 75, 60, it looks like 65. And my Q3 looks like, I'll say 95. My max score, it looks like somebody got 100 on this test. And my min score looks like about a 55. Okay, that's kind of a good, I'd be happy with that if I gave a test. Now, this kid over here, this asterisk is my outlier. So this might be a kid that just, you know, decided to take the test but didn't finish it maybe, or didn't come to school, hasn't made it up yet, whatever. So that person has a 10, okay? So that's called an outlier, and they'll put an asterisk for the outlier, okay? So you have to be able to read the numbers off the graph. You got to be able to put the numbers on the graph and take the numbers off the graph. Does everybody understand that? Now, these are the directions on how to do it by hand, all right? Or put it in your calculator. But I'll show you on the next page after we do dot plots. Colin. All right, now somebody did this nice dot plot for you. Now, when you have a dot plot, it's important. It says you have to make your own scale. Sometimes they'll give you the line. Other times you've got to make the line yourself. And then you've got to look at your data and say, how am I going to number this scale? And if you look up here, these low temperatures, they probably rounded them. But between, they all go by 5. So I started at 5s, counted by 5s to 50. So low temperatures across the United States. You have to put a title on here. After you put your numbers down, then you say, okay, hopefully the numbers will be in order. That makes it easier. I have 1, 2, 3, 4, 5, 6, 5. So I've got 6 dots above the 5. Okay, I've got 4 10s, 3/15. Now, when you look at data like this, you're able to look at the mode very easily. The most popular low temperature, you have two modes here, it looks like. Your mode is 25 and 40. So it's a pretty cold day across the United States, right? Those are all the low temperatures. Now, when you make these dots, you've got to make sure the dots are evenly spaced. I'll show you that when we get down here. All right, so now we're going to take a set of data and we're going to do two things to it. We're going to make first a box and whisker, and then we're going to make a dot plot of these. And there's only 12. It says the survey was taken amongst 12 people on the number of passwords they currently have to remember. So we're going to have our min, our Q1, our Q2, our Q3, and our max. And now remember, a lot of people get confused when I write Q2 here. Q2 is the median, same thing. Okay. Now we can plug these into our calculator, but a couple we can do in our head. What's the min of that data? 0. What's the max of that data? 6. The rest we can do in our calculator. Like I said, we could find the middle by doing it by hand. And actually, I could show you how to find the Q1, Q2. But we really want you to just be able to use your calculator on this unit. So stat, edit, go up here, clear out your list. Is everybody with me? Colin's not with me. Okay, everybody have their calculators? Yes. Opened. Steph, put this away. I want this away. Out of your ears. All right, so now, does everybody have their L1 cleared out? Yes. Okay. So, again, for the people who are just starting up again with me, you go to Stat, hit Edit. We're in our List 1. If there are some numbers in List 1, to clear it out, you go up to L1, hit the Clear button, and then down. If you hit Delete, you'll get rid of the whole L1, and then all your calculations will be off. Okay, so make sure you have an L1. Make sure there's nothing in it. All right, so now we're going to plug these in. It's easier to underline so you know how many of each. I've got 3 1s, 2 2s, 4 3s, a 4 and a 6. Okay, so 0, enter, 1, 1, 1. You're in. Come on. 0, enter, 1, 1, 1. Let's go. Now we're going to hit 2 times. Once, twice. And 3 4 times. 1, 2, 3, 4. And then a 4 and a 6. 4, enter, 6, enter. And it says I'm on 13, but that's an empty space. Remember, I had 12, and there it is. That's my 12th kid. So now again, I have to hit Stat, over to Calc, hit Enter. I think there's only one calculator that looks like mine in here. Everybody else has the 3 that go down, and you've got to hit Calculate. So go down to the third one, hit Enter on that Calculate, and you should get those numbers. Okay? Again, we are now looking at the bottom here. This is our 5-number summary. So I have 0, 1, 2.5. 0 I already had, 1, 2.5, and 3, and we already had our 6 filled in. Okay. So now you can possibly skip spaces on your number line. Here it's easy. I know I'm going from 0 to 6. I could do 0, skip 1, skip 2, skip 3, skip 4, skip. No, I don't have enough room. So sometimes you can make it a little bit bigger. So I'm just going to go by ones. 0, 1, 2, 3, 4, 5, 6. But again, if you had a longer number line, you could, to make a position for that 2.5 in your. So now I put a dot above every one of this 5-number summary. So my min is 0. My Q1 is 1. Q2 is 2.5. Q3 is 3. and the max is 6. It's really important when you do a box and whisker that your dots are floating way above that line. If you touch that line, you will get it wrong. Okay? Your points or your box or your whiskers, nothing can touch it. Okay? Now, our middle, our Q1, Q2, and Q3, like in the directions, it says put a line through your Q1, a line through your Q2, a line through your Q3, connect them, and that's your box. And then you need to label them Q1, Q2, Q3. Now you have to attach your min and your max. Your min goes from your Q1 and your max goes from your Q3. So this is my min, this is my max. Does anybody need more time to draw that? Now you have to do the IQR, or the interquartile range. Your interquartile range is your Q3 minus your Q1. And my Q3 is 3, my Q1 is 1, so my interquartile range is 2. Now we're going to take the same data and we're going to do a dot plot for it. You'll see on your classwork, they're going to give you a dot plot and you've got to go backwards with it. Okay? So here, how do we do a dot plot? Again, we're going to label it 0 to 6. And we have 1 dot above 0, 1, 2, 3 dots above 1, 2 dots above 2, 1, 2, 3, 4 dots above 3, 1 dot above 4, and 1 dot above 6. If you see, all my dots are evenly spaced. I can't make one column really small and one column really big. I have to space them out. Do you see how all my 1s look, they're in order, all my 2s are in order, all my 3s? Now, this is the tricky part to remember. This is why I say always put a title on everything. Because you do not need a title for the box plot, but you do need a title for the dot plot. So the title would be number of passwords. We could just say number of passwords. Okay, what's the range again? Colin, what's the range? Well, how do you find it? No, that's the interquartile range. The regular range is just the max minus the min. This is the regular range, max minus min. So it's going to be 6 minus 0. So the range of passwords is 6. Does anybody really have in here more than 6 passwords?
I do.
You do? Okay, so most people just have, 3, 4. They said here the average or the median is 2.5. So some people have 2, some people have 3. Okay. What is the mean and the standard deviation? So the mean, again, is your X bar in your calculator. This is a sample. You have to be able, they're not going to tell you. You've got to know. Is that the whole population of people? Well, they said they surveyed 12 people. So it's a survey of only 12 people. That's got to be a sample. All right? So we're going to go into our calculator again. And the mean, you got to remember, is that first one. We're going to say it's 2.4 for your mean. And your standard deviation is 1.6. So 2.4 and 1.6. What's the mode of this data? Which one happened the most? We can look at our dot plot. Which one happened the most? It was 3. Okay. So they're going to ask you, if you have a dot plot like you're going to see on your classwork today, you're going to have to take the dots and be able to take these and put them back into the calculator and then calculate all your information. All right. One more page. Okay, so now we're talking about a bell curve. All right. We're going to talk about when we do these things called frequency histograms. You may have remembered them as bar graphs from middle school, right? When you do a bar graph. All right, so when you do a bar graph, your intervals have to be equal. Do you see how your bars are touching here? If your bars are if there's spaces in between your bars, you will get it wrong. But we have to be able to describe these too. So like if I was graphing this, you kind of try to draw a shape around it. This is called the normal bell curve. It looks like a bell. In college, sometimes your professors will say, we are going to grade this class on a bell curve. Okay? If you're graded on a bell curve, not always a good thing. Your grade will be curved. Okay? Now, when we do these curves, when we trace them, this is the same on the right and the left. If you change it into a box and whisker, you'll see that all your boxes look the same. Another way of saying it is that it is symmetric. Now for these other two, when you draw the little curves around them, you're going to try to trace as close as you can to the outside of this, following. And then you'll realize that on one side is longer than the other. This side we call has a tail. The tail here is to the right. This is called skewed right or positive, and you'll notice that your box is larger on the right side. So on a box and whisker, if your box is larger on the right side, it'll be skewed right. If the tail is on the right side, it'll be skewed right. I'm just going to write it underneath so you guys have practice writing it. So this one is skewed right. It says it right up there too. When you trace the last one here, you'll notice that the tail for this one it's longer on the left, which means when you make your box is larger on the left here too. So this one is called skewed left. So these are the shapes of histograms, whether they're skewed right, skewed left. Some histograms are exactly just a little bit off. These could be maybe like McDonald's French fry sales. I bet you their French fry sales are pretty much uniform. They probably don't change much every day, right? French fries are one of their big sellers. When you drive by McDonald's, you'll be amazed when you start your little babies eating McDonald's at 2 years old, and they can read at 2 the McDonald's sign, and when you drive by, they start screaming, fries, fries, because they want their fries, right? So, does Madeline know McDonald's sign?
We don't go to McDonald's.
Oh, you don't? Just wait when she has number 2. She'll be like, I want McDonald's. So uniform distribution means it probably doesn't change much. You see how it's like there's no tail on it? It's kind of the same. Here, though, we have, if we trace this one, we have like 2 peaks here. When we have 2 peaks, this is called bimodal distribution, because you have, again, 2 peaks. Okay, the best measure of center to use when data is skewed. When data is skewed, the best thing to do is the mean, the median, or the mode, do you think?
Mode.
Well, if it's skewed, that means remember it's got a tail on the right or a tail on the left. That means that there's probably a what? If there's a really long tail, there's probably a what? Outlier. When we have outliers, what do we usually use?
Median.
The median. Okay? Now you have to identify all these shapes. Which one? What is this one?
Skewed right.
Skewed left. Yep. That's okay. Skewed left. All right, how about this one? Let's try to draw one around here. Let's see. Does that look like it has a tail on either side? No. So what was that one called? This is the normal bell curve, or symmetric. So we can call it the normal curve, a bell curve, or symmetric. They'll use all those different names. How about this one here? These are our French fries. What do we call them? Uniform. I'm assuming that French fry, but it could be coffee sales too. Coffee sales are pretty much the same, right? People that drink their coffee go every day, like Mr. Mussolino, right? How about this one? This one, the box is bigger on which side, right or left? Right, so this one's going to be called skewed right. Okay.